All right, if you're having trouble with absolute value equations and inequalities, in this video, I'm going to show you how to solve them. Now, if you're just here for inequalities, then you can fast forward through the video and those will be covered in the latter part of the video. But to start out, when we say the absolute value, right? We probably have heard, oh, the absolute value means both positive and the negative value of some number, which it does. Now, when we're solving an absolute value equation, right? Remember what we're saying with this is the absolute value of what will be equal to 4. And so that always means there's going to be two things x can equal here, right? And that doesn't change even if I have the absolute value of something other than x equals 4. We're still saying the absolute value of whatever this in here is equivalent to is 4. That means whatever this inside of the absolute value bars is could be 4, or it could be negative 4. So this is what you always want to do. When you have an absolute value equation, you're going to break it up into two separate equations. And of course, for each of these, this one, I'll get x could be 1. Or if I subtract 3 here, we get x could be negative 7. Now, when I have a more complex equation, so let's say I have something like 3 minus 2 times the absolute value of 2x minus 1 equals negative 1. We essentially want to look at this and you almost treat the absolute value portion right here as what you're solving for initially. It's almost like this whole thing is x to start out. So we want to isolate the absolute value bars. Well, that means the first thing we're going to want to do is subtract 3 on both sides. If I do that on the left, I'm going to have negative 2 times the absolute value of 2x minus 1 equals negative 4. And then the next step I'm going to do is I'm going to divide both sides of this by negative 2 so that I isolate my absolute value expression. And that'll be negative 4 divided by negative 2. That's positive 2. So now we are ready to break this up into our two separate equations. We know 2x minus 1 could be equal to 2, or 2x minus 1 could be equal to negative 2. In both cases, remember, as long as whatever's inside of here, when I take its absolute value, I get 2, then I'm solving this equation for x. So here I'm going to add 1 to both sides and I'll get 2x equals 3. Divide by 2 and I get x equals 3 over 2. And over here, I add 1 to both sides, and I get 2x equals -1, divide by 2, and I get x equals -1 over 2. Okay, so the key here, you always you solve for your absolute value portion first, then you take whatever's inside of there and you set it equal to both the positive and negative version of this number. Now, there's one exception. There's one thing you need to watch out for. And that's if my original problem, or whenever I get to the point where I have the absolute value bars isolated, if this is equal to a negative number, well, think about it. The absolute value of what is -4? Well, that what can't be equal to anything. There's nothing I can take the absolute value of and get a negative result once I do that. So right when we get to this point in any problem where we have the absolute value bars isolated and it's equal to a negative number, we can stop. We're done. There is no solution. Okay? All right. Now, as far as solving inequalities goes, so a lot of what we just said is going to carry over to inequalities. If I had, let's say, this same problem right here, okay, except it was an inequality problem. So something like x plus 3, the absolute value, is greater than or equal to 4. Well, I'm still going to go ahead and break this up into two inequalities. And the first one's going to be x plus 3 is greater than or equal to 4. And the second one, just like before, I make it -4, except I also flip the inequality. So we break it up into 2. We repeat what we have, just like we did on the equals one. And then for the second one, yes, we make this number negative, but we also just flip the sign. Whichever way it was here, it gets flipped the other way here. And then we just solve. We subtract 3 here, and we get x greater than or equal to 1. Subtract 3 here, we get x less than or equal to -7. Now, this is what we call an OR answer. And a lot of the time you end up having to express your answer on a number line. So in our case, it would look something like, let's say 0 is here, 1 is here, -7 is like roughly right here. We're saying everything x is greater than or equal to 1, or x could be less than or equal to -7. When you have 2 arrows going in opposite directions, that's when it's going to be an OR solution. When you have your 2 solutions and everything in between them, that's when they'll have you write and. You know, for example, if I had a solution, let's say I had this instead, right? If I solve this all the way down, I'm going to end up with x is less than or equal to 1, x is greater than or equal to -7. So on a number line, the same number line, right, that's going to be everything less than or equal to 1. And then I'm going to come over to -7 and realize, oh, it's greater than or equal to -7. So boom, that right there is an and problem. X is less than or equal to 1 and greater than or equal to -7. Okay? And of course, solving this would be the same as over here. I would do the same things, right? I would have, my first one would be less than or equal to 4, and then my second one would be greater than or equal to -4. Okay? Now, one thing that you need to watch out for, okay? Similar to what we talked about down here, where this can't equal a negative number, with inequalities, I can't have anything that looks like this, for instance. Here I'm saying what? The absolute value of what is negative? That's what less than 0 means. Well, there's nothing, right? There's nothing I can take the absolute value of and get a negative answer. I mean, this would be the same. It wouldn't be any different if I said less than -2, right? Both of these, I get no solution. Okay? Now, similarly, let's say I have x plus 3 is greater than or equal to 0. Well, I don't even need to solve this or anything. I already know literally anything is going to work for x here. No matter what I make x, if I'm taking the absolute value of this entire quantity, I'm always going to get either 0 or a positive number. It's impossible to get anything else. Okay? So there's a couple situations with inequalities that you need to watch out for. And these are those situations. Sometimes you just have to think about it. Like if I have a negative number or I have 0 on the right side, that's when you're going to encounter this, and sometimes just kind of have to think it through. All right, let's look at one more sort of, I guess, more complicated example. What I'm going to do is, again, I'm going to do the exact same problem we did over here, okay? And let me just star all these so that we know everything here is separate. And right here, we'll do the next one. So we're going to do 3 minus 2 times the absolute value of 2x minus 1 is greater than, let's see, let's do greater than or equal to -1 so that we follow the one over on the left side. So again, first move, subtract 3 on both sides. So we have -2, absolute value, 2x minus 1, greater than or equal to -4. Now our next move, we're going to divide both sides by -2 so that we isolate the absolute value. But what do we have to do? Remember, whenever you divide or multiply both sides of an inequality by a negative number, you have to flip the sign. All right, this is crucial. You remember this for any inequality problem, not even just solving absolute value inequalities. That's just in general. So we're now at the step where we can split this up into two inequalities. We know 2x minus 1 could be less than or equal to 2. We also know 2x minus 1 could be greater than or equal to negative 2. We add 1, so we get 2x less than or equal to 3. We divide by 2. X is less than or equal to 3/2. Similar over here, we're going to add 1, then divide by 2, and we'll get x is greater than or equal to negative 1/2. Now, we don't even have to write the word and or yet. We first can just put it on a number line, and that sort of helps you sometimes visualize which one it's going to be, and or. Well, x is less than or equal to 3/2 and greater than or equal to negative 1/2. So that's going to be everything in between these two numbers. So that's an and problem. Okay, one last thing. When some classes might have you write the solutions a bit different. So just to demonstrate it, let's say we had, like on this one up here, for instance, they might have you write something like x exists on, and you may not even have to write that part, but this is the key part. They'll do something like this: negative infinity, comma, -7, and you put a bracket when you want to include the -7. So that's everything from negative infinity up to -7, or, and you do like a U shape, or 1 to positive infinity. And the infinities always just get a soft bracket. Okay. If I were doing this for this problem down here, for example, I'll just write it here, right? What we would end up doing is saying x exists on, and in this case, it's just negative 1/2, comma, 3/2. And we're including both of them because it was a greater than equal to problem. And we don't need any infinities and such because it was just between these two numbers. All right, and that pretty much sums it up for our inequalities and equations of absolute values. Thanks.